part of that, so designing satellites and rockets and things like that. I also got my master's from Colorado in engineering management. But like I said, my job is actually not specifically in engineering. Engineering has definitely benefited my job, but it is in IT consulting with a firm called Accenture. Again, you may or may not have heard Accenture. I'll tell you a little bit about that. After we talk about some of the things that I did in my undergrad related to engineering. So one of the, actually before we do that, excuse me, I want to tell you a little bit personally about myself. One of the big things about me is I love to travel. I've been to nearly every continent for both personal and work travel. I do love to travel. Some of the pictures here are from my Africa trips. I've also been to Latin America, Central America, again for work and pleasure. And I've also done, I'm currently working in the nonprofit sector, doing some nonprofit consulting. So working with international nonprofits, still in technology, so it all kind of comes around. So with that, I did want to tell you about my most significant engineering experience. So this is still while I was in school, while I was an undergrad at University of Illinois. Something called the Float Illini. You may or may not have heard of this program with NASA, but it's a pretty cool program. Basically, they have a plane, it's the KC-135, that simulates microgravity. And so microgravity is basically floating around as if there's no gravity. So as you can see on the right-hand picture, that is me in microgravity. This is actually produced by the plane based on some maneuvers, which we'll talk about in a second. And the program is basically, NASA reaches out to universities and says, hey, do you want to do some sort of science experiment in microgravity? You take about a year to design an experiment, you submit it to NASA, and then you actually get to go to Houston. I was able to go to Houston with my team and run an experiment in microgravity. So it was a lot of work, it was a lot of research. We did have to design a project from scratch and actually build it, but it was also a lot of fun. It's a unique experience. The only people besides students who get to fly on the KC-135 in microgravity are astronauts. This is where astronauts train. The other people that are let onto the plane are filmmakers. If you've seen the movie Apollo 13 with Tom Hanks, and all those shots where he's kind of flying through the lunar craft, those were filmed on the KC-135. So I'll show you some more pictures of the plane and of us floating around and all that good stuff. But I wanted to tell you about this group because definitely relates a lot to engineering. And I know you talked about the engineering design process. So I'm going to tell you a little bit about the experiment I did and what that was like on the KC-135. So just a little bit of background on the weightlessness that you experience on the KC. The way it simulates weightlessness or microgravity is the plane flies in what we call parabolas. So basically, the plane turns on its engines. It starts going up at a very high angle, and then it turns off its engines. Once it turns off the engines, you're basically falling at the same rate as gravity. So therefore, you don't feel gravity or the weight of gravity as you would on Earth. So therefore, you just start floating around. Then the plane basically starts to dip because there's no engines, and then they turn the engines back on, and you pull up again. When you're pulling up, it's even a heavier weight than as if you're on the surface of the Earth. So it's almost 2 Gs. So it's an extremely heavy weight. You do this over and over again. You do about 20 or 30 parabolas. Each weightlessness period is actually only about 20 seconds long. So you have to be able to conduct your experiment in that 20-second window. So that's just a little bit about the KC. And I wanted to talk to you about the project we did and how it relates to the design project process and how that's sort of a thought process that we use in engineering quite a bit. So I believe this is the design process that you've talked about before. When we decided that we wanted to do an experiment and get to fly in the KC, we said, okay, we first have to define our problem. What's the experiment that we're going to run? So basically what we decided to do was an astrobiology experiment. And we took these little guys here, they're called Artenia. You might have heard of brine shrimp or sea monkeys. You get them in the little packets and you put them in water and they just kind of swim around. They're just tiny, tiny little shrimp. So what we decided to do is we wanted to say, okay, if you put Artenia in microgravity, how do they swim around? So on Earth, they just have normal swimming patterns because of the gravity. But once you put them in microgravity with zero gravity, will they be able to know what's up, what's down, how will they swim around? So that was our problem. That's what we wanted to figure out. That's how we established our project initially. So then comes the process of actually doing all of the hard engineering work with regards to developing the proposal, designing the project, all that engineering stuff that goes along with projects. So one of the things that we had to do is we wrote a proposal, a detailed explanation of what we were doing, how we were going to build the experiment, all that good stuff. One of the did is we used a CAD program called Inventor, so CAD is computer-aided drafting, to develop what the experiment was going to look like. So this is actually something we had in our proposal. I know it's a bit small here, but you can see these black boxes here are some cameras. And then these orange straps are on some tanks, which is where the Artemia, the brine shrimp, were going to go. And then we were basically going to put this on the KC and then take film of the brine shrimp and see how they swim around in microgravity. So this probably took the most effort, actually designing and creating the proposal and actually doing all that work up front. Generating the concept and developing the solution.
Just so you know, we're going to learn to make drawings like that fancy one we had on the bottom left. So we're going to be using Autodesk Inventor Body for that.
There's some other ones actually done in Inventor, so we'll actually be creating some of these guys. The next thing we did was, now that we had the pretty picture of what our experiment was going to look like, and we had done the research, written the concept paper, all of that, we said, okay, now we actually have to build the thing. So one of the things you'll discover in engineering is everything looks really good on paper, but when you actually go and you develop things and you actually put stuff together, it doesn't always work out as planned. So that was one of the things we discovered when we were building our experiment. We started with one drawing here, which you saw before. This was our initial thought. And then as we were actually building things and looking at the design specifications provided by NASA, and we had to do safety testing, all that stuff, we finally ended up at something that looked like the right side of the screen here. Which is, as you can see, same general concept. We've got tanks with brine shrimp and cameras and all that. But that's what we actually ended up doing. And what's kind of cool is that image is quite close to what the final product looked like, minus all of the duct tape. That's pretty much what we ended up with. So you can see here, it's a little bit, again, the lighting isn't great here, but you can see here are tanks with some brine shrimp. And then here are cameras that are aimed at the tanks with brine shrimp. So we actually built it, and we actually sent this thing to Houston. We actually got it on the plane. So that leads to our final part of the design process after developing and researching and designing and testing. Now we're in Houston. My team is in Houston, Johnson Space Center. We've got our experiment on the plane. We've done all the safety training, all of that. And now we actually get to conduct our experiment. So that's the fun part of all of this. So these are actually photos from when we were able to conduct the experiment. This photo here is actually taken from the plane. Again, this is just a regular, similar to a commercial jetliner, so just like a plane you would take going out of the airport. But you can see here there's an extreme angle on the horizon, and that's because the plane is nosing up at nearly 45 degrees. So this plane is taking a very big nose up to go up the parabola, and then soon it's going to drop and cause weightlessness. So that's what this picture is right here from our aircraft. And here's a zoom in of the brine shrimp tanks. And you can see an air bubble in the water there, and then you've got this camera kind of taking pictures of what's going on with the Artemia, with the brine shrimp. So we did a lot of work. It was a lot of effort here, we also got a lot of valuable data while we were on the plane and conducted our experiment. But we were also able to have a little bit of fun as well, because hey, we worked really hard, so we got to play around in microgravity as well. So as you can see, this plane here, you can see this is sort of the fuselage of the plane, and then we're all sort of floating around in here, and you can see the plane is covered in this white puffy stuff because you literally are kind of bouncing off the walls, so they don't want anybody to hurt themselves. We also did some fun experiments. You can see myself on the right-hand side of the screen just kind of throwing things around, and we took video of that to see how things reacted in space. So all in all, Float and Line, fabulous experience. Learned a lot about engineering. It was a very hands-on experience that I didn't necessarily get in, say, a senior design class or my regular courses. So this was a great way to sort of level out my college career by doing something extra, something on the side, some really hands-on research stuff. And I got to fly in microgravity, which is pretty cool. All right, so with that, I spent a lot of my undergrad focused on engineering. I did aerospace engineering and did Float and Line, so why am I an IT consultant? What is that exactly? So again, you may or may not have heard of consulting, but to clarify what the heck consulting is just simply a professional who's an expert in a certain area. You can have lots of different types of consultants. I've got some samples down here. You can have a financial consultant. You can have an IT consultant like myself, marketing, business, all sorts of different types of consultants. And they're just people who are experts in their area. So if you ever hear the term consultant, don't get too thrown by it. It's just someone who specializes in a different area. They often are on short-term projects as opposed to working for a company, an engineering company, for years and years on perhaps the same project. Consultants tend to jump from project to project. Also, there tends to be travel involved, where you travel from client site to client site. Not always, but that's often the case with consultants. So just a little bit about the company I work for. Again, may or may not have heard of Accenture, but a very large consulting firm. We specialize in technology consulting, but we also do business and financial consulting as well. Been around for a while, and some other stats you can read up here, but the big thing to take away is we're a company of 266,000 people. We're a really big company across 55 countries. So one of the things I love about Accenture is that I have lots of opportunities to do lots of different things at Accenture. I can also do them on a global scale. I have worked internationally with Accenture, and I've really enjoyed those experiences. I wouldn't be able to do that with a lot of companies that don't have such a global presence like Accenture. I'm going to show you a quick video on